Let's do another example of a hypothesis test for means. This example says, according to a study in 2015, the mean number of text messages sent and received by teenagers daily was 5,000. Suppose another researcher wants to dispute this claim to see if the mean is different from 5,000. A random sample of 100 teenagers yields a sample mean of 5,350 texts with a standard deviation of 1,500. Perform the hypothesis test with a level of significance of 0.1. So from all of that, in 2015, the mean number of text messages sent and received by teenagers daily was 5,000 messages. This researcher wants to see if the mean is different from 5,000. They took a sample of 100 teenagers. The sample mean was 5,350 texts. Standard deviation is 1,500. Perform the hypothesis test, that's what we're doing, with a level of significance of 0.1. So mu x bar s n and alpha to get me started. It's just a really funky looking alpha. So the previous mean that we know of was 5,000. The new sample mean that we found was 5,350. The standard deviation was 1,500. The sample size is 100, and the level of significance is 0.1. First thing, write out the null and the alternative. So we have our HO and our HA. Our null is going to say mu equals 5,000, and our alternative is mu does not equal 5,000 because of the word different. They don't know if it's greater than or less than 5,000. They just want to see if it's different from 5,000. Step 2 is the test statistic. Using our t-score equation. This would be a great place to pause, see if you can get the t-score, and then resume. X bar is 5,350. Mu is 5,000 divided by 1,500 over the square root of 100. Again, if I put everything that's on top in parentheses and everything that's on bottom in parentheses, I can do this all at once. And this one gives me 2.3 repeating, so I'm going to write down 3 of those repeated 3s. So 2.333. Now for the p-value. Now in Excel, we have a specific function for a two-tailed test, just like we did for the right-tailed test. So equals t dot dist dot 2t, and you always want to plug in the positive t-score. So what I'm going to do is I'm going to write it like this, and then I'll explain this in a second. And then the degrees of freedom, which I'll remind you what that means in a second. So this is what I've done here is I've written the absolute value of t. So what this means is the positive t-score. Those two straight lines next to the t means if it's negative, make it positive. If it's positive, keep it positive. So you want to put in the absolute value of t, so the positive value of t. And then the degrees of freedom is n minus 1. So for this one, t dot dist dot 2t, our t-score was already positive, so we didn't have to worry about that. And what's our degrees of freedom? df equals 100 minus 1. So degrees of freedom is 99. And I'll just show you real quick. If I try to plug in a negative number, so t.dist.2t, I'm going to try and plug in negative 2.333 and 99. Okay? If I hit enter, I get an error message. Because this function, t.dist.2t, will not let me plug in a negative number for the t-score. It looks at that and it says, hey girlfriend, you need to plug in a positive t-score. So t.dist.2t positive 2.333, comma 99. Now when I hit enter, I get the probability. So if you try and plug in a negative and you get an error, turn the negative into a positive. Nope, that's not what I wanted. This is the direction I want. So 0.0217. So that's our p-value. So we're going to look at our conclusion and our interpretation. So conclusion, is our p-value less than our alpha? Is the probability too small? So is 0.0217 less than 0.10? Yes. If P is low, reject HO. Reject the null hypothesis. So what does this mean? We've rejected the null. This means that there is sufficient evidence. The evidence is our small p-value to support that the mean number of text messages sent and received daily by teenagers is different from 5,000 messages. Now, even though it looked like it was bigger, we did not test if it was bigger. So we cannot say that it's bigger. All we can say is that it is different because that's what we tested. Our alternative hypothesis, back up here, was different, not equal to. So when I do my conclusion and my interpretation, all I can say is that we can support that the mean number of text messages is different from 5,000 messages a day. We cannot say it's greater than, even though the sample mean was bigger than 5,000. We cannot say that. All we can say is different. So that is how you do a hypothesis test for means when the alternative is two-tailed.